Hi, so thank you for having us. My name is Alan Lundgard. Today I'll be talking about ongoing work at Stanford University Libraries on automatic speech recognition tools for audiovisual media. This work is conducted with a fantastic team, some of whom are present today. This team helps to maintain the Stanford Digital Repository, which houses over 50,000 hours of audiovisual content. This content should have textual captions, subtitles, and transcripts, which, as noted, are important for accessibility, search and retrieval, and overall better user experience. It's not quite the National Library of Sweden, but 50,000 hours is still quite a lot to transcribe manually. So automatic speech recognition, or ASR tools, can help to generate this text. That said, it can be challenging to know which tool to choose. There are many available. And so the goal of our testing so far has been to understand the various capabilities and limitations of these tools. We focused on those highlighted here, including Whisper, Amazon Transcribe, and Google Speech to Text. I want to say up front, for a more in-depth introduction, I highly recommend the AMIA Whisper panel, which is linked here. We took inspiration from this panel and also from a recent AI for Lamb Whisper community meetup where participants noted particular topics of interest. And so we focused on the first two highlighted here, selecting a model and specifying parameter values. So to test these different models and tools, we selected a test set of 10 audiovisual media items from our repository. These are representing diverse qualities, languages, and durations, such as inconsistent audio quality, multilingual speech, content containing acronyms, jargon, proper nouns, music, and so on. And each of these items has a quote unquote ground truth human authored transcript from the Rev transcription service, which we use as the baseline comparison for our model output. It's important to note here a caveat, which is that Rev claims to be 99% accurate, but is not always, as we will see later on. So it's an important but imperfect ground truth, and the best we have at this time. So our approach consisted of three distinct phases. First, we test pre-processing the audio with different filters prior to inputting the media to the Whisper model. We also tested selecting different model sizes, specifically the multilingual models, and specifying different parameters as input. And then we compared our different Whisper model configurations to other ASR tools like Amazon Transcribe and Google Speech to Text. On the Whisper side, since we conducted that on premises, the testing was done on a GPU workstation, which was generously provided by our colleagues in Research Data Services. So many thanks for that. So the first phase of testing, before inputting media to the Whisper model, we can apply filters to the audio to hopefully improve the model's transcription capability and output. These filters include things like denoising, adjusting volume, high pass, low pass, and so on. We tested 6 filters from FFmpeg, which are here listed in order of best to worst performing on our test set. And we found that often, but not always, the Whisper output improved with this pre-processing, but it really depended a lot on the particular qualities of the audio file. I won't get into too much detail here, but we can return to that in Q&A. For our second testing phase, we focused on Whisper multilingual models and their various input parameters. There are upwards of 14 or so different parameters, that is, variables that can be specified as input to a model. Some of them are listed here. Most of these have default values that are set quote unquote out of the box, which are already optimized by the Whisper authors on their own test data. So you don't have to worry about these parameters if you don't want to, but we were curious if we could achieve better results by perturbing some of their values. So in order to test this, we selected a subset of these parameters, which seemed most likely to have an effect on output quality. Again, they're listed here. I'm not sure if you can see my cursor. Um, and since these parameters, best of, beam size, patients, condition on previous, etc., they all interact with each other in the transcription algorithm. So we tested all possible combinations. So taking all possible combinations of these parameters and values, we end up with 48 unique test configurations. So this chart represents the results of this testing. It's a bit difficult to parse, so I'll walk through it. Each row in the chart is a unique parameter configuration, one of 48. Each configuration is faceted by model size. So we have the medium model, the large model, and the large V3 model. And for each configuration, we calculated the average word error rate across our test set. I won't get into detail about what word error rate is. The thing to understand for a general audience is that error rate is the inverse of accuracy. So in this visualization, the smaller the bar, the more accurate. For each of our different models, we highlighted the default configuration, the out-of-the-box configuration in gray. So right off the bat, we can see that perturbing these parameters in some way does affect the quality of the output, especially for the larger models. We can see that the default configuration is lower performing than many of our perturbations. But apart from that, it's kind of hard to identify any consistent trend, with one big exception, which is the condition on previous text parameter, which I've highlighted in yellow. We found that this parameter interacts with model size and accuracy in a consistent fashion. So specifically for the medium model, setting condition on previous text to true, which is the default, is always more accurate on our test data, whereas for the larger models, setting this parameter to false is always faster and more accurate. So the implications of this could be if you have GPU resources to run the larger models, you should think about flipping this switch off to get an accuracy boost. If perhaps you only have resources to run the medium models, then you should leave the default settings as is. You can check out the appendix at the end of these slides for more details on our most accurate model configuration. In addition to that quantitative testing, we also did qualitative analysis. Again, there are way too many details to get into in this talk, so I encourage you to check out the appendix, which goes over our method and some observations. But I just want to touch on a couple of noteworthy findings, especially related to multiple languages. The Whisper multilingual models can transcribe audio that contains multiple languages, sometimes even within the same sentence. So in this example here, which is our student hunger strike media item, the speaker switches from English to Spanish mid-sentence, and the Whisper model was able to capture that, whereas the human transcriber skipped over that Spanish language content completely. Similarly, Whisper can transcribe proper nouns that might not be familiar to the human transcriber. So in this second example here, in our Native American Research Forum test item, Whisper correctly transcribed the Passamaquoddy, which is a Native American tribe in Northeast North America, whereas the Rev transcriber interpreted this as, quote, a past inequality, end quote. And there are many similar instances like this. So those are some of the benefits of Whisper's multilingual capabilities, but of course there are pitfalls as well in the form of hallucinations. It's fairly well known that Whisper will hallucinate intro and outro utterances like thank you for English media or gracias for Spanish media. And we also noted significant and frankly strange hallucinations during instrumental music, background noise, gaps in speech, any kind of non-speech sound, Whisper had a tendency to want to insert some content there. So here, for example, during tango music, the human transcriber accurately noted music with the music note icon, whereas Whisper appears to hallucinate cooking recipe, which is delicious but erroneous and would need to be manually corrected. That said, Whisper then went on to correctly transcribe the English language content that was missed by the human transcriber. So the third phase of our testing compared our Whisper model configurations to some of its competitors, in particular Amazon Transcribe and Google Speech to Text. Those prior pitfalls that I just mentioned, notwithstanding, Whisper still really did a lot better than its competitors in those cases. Our optimized Whisper configuration outperformed the default Amazon Transcribe and Google Speech to Text on 9 out of 10 of our test items, which is shown here. So again, word error rate means the smaller the bar, the better. Whisper outperforms, except in the case of a Spanish language item here, where Amazon Transcribe in blue outperformed. An important thing to note here as well is that these are the default settings for Amazon and Google, so it may be possible to improve their performance as well with additional optimization. Not shown in this visualization is a comparison of all the defaults across the board. And in that comparison, we found that Whisper outperformed on 6 out of 10 test items. Some takeaways from this analysis, Amazon Transcribe seems to be the closest competitor to Whisper. Their default models are pretty comparable, specifically the Whisper large model with the default parameter settings. As mentioned, Whisper tends to do a lot better when you optimize slightly with this condition on previous text flag. And across the board, Google Speech to Text was consistently the least accurate of our test items. We also noted that Whisper excels at transcribing distorted speech, which I think is consistent with some of the results that Lenora had mentioned earlier. As always, there's much more to investigate, including testing Whisper's translation capabilities. Speaker diarization is important to us for accessibility reasons, which Whisper does not support out of the box, but I understand there are some modifications that do support that. And Amazon Transcribe also does support that, so that could be an important point of comparison. We would like to build a remediation workflow, including a UI for correcting auto-generated transcripts, as well as testing other tools that we might wish to integrate into that workflow. Again, special thanks to Peter Leonard and Research Data Services for providing the GPU resources, and many thanks to our colleagues at Digital Library Systems and Services for all their ongoing support. And thank you for listening.
Well, thank you, Alan. So we have come to the end for the presentations, but there are, as far as I can see, a couple of questions for you, Alan, at the end of the agenda document. Can you see it?
I can. I'm looking over the questions now. The first question is, did you try setting particular prompts as an argument for Whisper? If so, how did you select the prompt? And we did not try that. I understand that that's possible to do. For example, you could prompt the model with a dictionary of terms that you know might appear in the media item if you had sort of jargon or sort of special terms, but we did not do that. And still, in many cases, Whisper was able to correctly transcribe our even institutional specific terms and acronyms. It did pretty well with proper nouns, as mentioned in the slides, the Passamaquoddy, et cetera, and some other proper noun cases. Another question is, did you try other metrics other than word error rate, like semantic distance? And I believe we did. I think I can maybe defer to my colleagues on the specifics of that question, but I think we used a package, I believe it was called GWER, which calculates a handful of metrics like word error rate, word information lost, and others. And I'm not sure about semantic distance specifically, but for the purposes of this talk, we just reported out word error rate. Although I know there are nuances between what those different metrics convey.
Oldman, I think you had a comment.
Yeah, it's we had problems with silence as well. We had an entire long lecture about uh, stomach problems from in our medical school, which was totally gibberish, and some of it was actually well, not very nice words and things, and all of that was because of low sound levels, and for instance, Whisper X just eliminates all of that. So there are tools that can help with many of these things and also give better performance and also add things like diarization. So there are lots of add-ons you can use, and you can generally use them with different models as well.
That's great. Thank you so much. I actually wanted to ask you what you were using for diarization, so you already answered my question. Thank you.